Okay, guys, happy dash dash dash. This is the sixth video on lanthanide and actinides. So today we'll continue with our separation of lanthanides part, and we'll be discussing ion exchange resin method. Ion exchange resin method. Okay. So ion exchange resin method is the most important, most rapid and most effective general method for the separation and purification of the lanthanides. How does this work out? What you have is a uh, solution of lanthanide ions is run down a column of synthetic ion exchange resin such as synthetic ion exchange resin. See, understand the meaning of this synthetic ion exchange resin. So one example is of Dovex 50. It's a commercial and industrial name, synthetic ion exchange resin. So what happens is you have a column, you have a separating, you would have seen it'll be just like a your got to give a very mm, rough analogy. It is like, there is there is a burette kind of thing. Okay, now what happens is along the walls of the column in Dovex 50, in Dovex 50 there is sulfonated polystyrene. Okay, fine. So what is styrene? If you know styrene, it would help you if you knew this much. Styrene is, okay, this is your styrene, right? Now a polystyrene would be something which when this acts as a monomer, okay, and it's connected with it's chained with n number of styrene molecules, then that is when it becomes polystyrene. So simple way to represent that would be, see, this is your example of polystyrene. Okay, now a sulfonated polystyrene would be something where now this hydrogen, okay, is replaced by a what is a sulfonium group? If you this much should at least, okay, this is your sulfonium group, right? Now this hydrogen in all of these monomers is replaced by sulfonium group. Okay, so this is your styrene, this is your polystyrene, this is your sulfonated polystyrene. So if I have to write it again, it is So now what happens is a solution of lanthanide ions is run down this column of synthetic ion exchange resin. Okay, along this column you pour your mixture of lanthanides which you want to separate. Okay, so what happens is Ln3 plus is Ln3 plus can be absorbed Ln3 plus ions are absorbed. Let me mistakes here. Sorry. Ions are absorbed onto the resin and replace the hydrogen atom so 3H. Okay, so the equilibrium that is set up is something like this: Ln3 plus, which is aqueous, plus 3H resin, which is a solid, Ln resin 3 aqueous. Okay, so the hydrogen ions produced are washed. Now the hydrogen ions that are produced are washed through the column, the H plus ions. Okay, so now where are the metals? The metals are on the resin. Okay, now these metals are eluted. The metal ions are eluted, that is washed off in a selective manner. Okay, so there are many eluting agents. One of the eluting agent we'll use here is citric acid and ammonium citrate. Is a complexing agent. For example, a buffered solution of citric acid and ammonium citrate. Okay, so this is a buffered solution. So now let us consider this case and see how the equilibrium is set up now. See what happens is Ln resin 3 plus 3H plus citrate 3 minus 3H resin plus Ln citrate. Okay, so this is the equilibrium that is set up, which means now lanthanide, as the citrate solution flows down the column, Ln3 plus ions are removed from the resin. See, they are removed from the resin. Okay, and form the citrate complex. This is a citrate complex. Ln3 plus and citrate 3 minus form the citrate complex. As they flow down the column, what happens is a little lower down the column, Ln3 plus again goes back to on the resin. Okay, so what happens is Ln3 plus keeps shuttling between resin and citrate ion. So you have to understand this dynamic. This is where the whole story is all about. At one point of time it is on the resin, at second point it's on the citrate. Next it's there on the resin, next it's there on the citrate, next it's there on the resin, next it's there on the citrate. So it keeps, you know, alternating between resin and the citrate. Now, as the citrate solution runs down the column, the metal ions form complexes alternatively with the resin and citrate solution many times. So it keeps on happening. This here, once here, once here, once here, once here. So again, it keeps up happening. The smaller lanthanide ions, such as Lu3 plus, form stronger complexes. Take down this sentence. Very important. The smaller lanthanide ions, such as Lu3 plus, form stronger complexes with the citrate ions than do the larger ions like La3 plus. Okay, so what is the reason? Reason क्या है इधर? See, the reason is the size, is the shape and size of this citric acid. Citric acid का क्या है? Citric acid structure is, okay. See, now what happens is, here, suppose your ion is very very big. Your ion is this big. Now this citrate ion will not be able to hold it. See this other case, if it is only this much, okay, the smaller lanthanide ions, what happens? This is held very tightly by a citrate ion. Thus, smaller, heavier ions spend more time in citrate solution and less time on the resin. So what happens is, therefore, these are eluted from the column first. So the smaller and heavier lanthanides are eluted first along with the citrate ions. So based on their size and how effectively they bind to citrate ions, different metals are eluted separately into bands. So the differential factor is again the size here. And the progress is followed spectroscopically by atomic fluorescence. And the solution leaving the column is collected by means of automatic fraction collector in separate containers. Collected by means of automatic fraction collector in separate container. Okay, so this is how individual elements can be separated. Okay, so the metals may be precipitated as this is how the metals may be precipitated as insoluble oxalates. From citrates to you can convert to oxalates and heat it to give oxides. Fine. Now, how do you increase the purity? Acha, so see, a simple technique, a puncture shop day to day technique you can do is can use the long column to avoid overlap of ions. So this is how you increase the purity. I mean, you distinctively separate one lanthanide from another. There is no overlap of ions here. So this was your sixth video. I hope you are going through these videos and benefiting out of that. Any questions or doubts, please reach out to me. Thank you.